All right, so yesterday we plotted the points for the different scenarios and looked at what we thought the relationship was, if it was a positive, negative, or no association between the two sets of data. So today we're going to draw a line of best fit. And a line of best fit is the line or the function that best represents the trend. So we're trying to do that by balancing the data points on either side so that we don't have the line really skewed. So I'm going to do an example on here. So you can see these blue points. I'm going to try and place a line in between them where it keeps it fairly symmetric on both sides. Here's a non-example. If I were to draw a line like this line maybe fits 2 of the points, but all the rest are above the line. So that's not a great example. This is also not the best example because I have most data points, but 2 of them are on one side of the line. So I want to try and make it balanced. So it's not going to be perfect just when we do this by hand, when we approximate, but you can try it out with a ruler and adjust. It looks like 2 points on the left and 2 points on the right are fairly evenly distributed, but then I have that third point. So maybe just a hair more in between, something like that might be a good line. So I'm going to now actually draw this. Use a different color. And because I'm doing this on my iPad, I can adjust my line, but if you're doing this by hand, you may want to play around with your ruler for a bit before you draw your final line. So I want to try to get most values maybe like that. And like I said, I can adjust this to try and fit evenly between most. Something like that. Looks pretty good. Okay, so we have the line. Let's look through what the questions are going to ask. What does the slope appear to be for your line? Make sure you check your units and spacing. So this is where we want to zoom in a bit and try and find where the line's going through an easy value. So these are going by 2s. So if I can find one that looks fairly symmetric, I think this is a pretty good point here. That point is 82.26. And then it's hard to find a second one this one actually goes pretty well through. This one is 72.15. So you want to choose the 2 points strategically based on values that go exactly through either a grid mark or maybe looking like halfway. There might be times where you have to approximate, and that's okay, but it worked out with my 2 lines that these are close enough. All right, so now I'm going to actually calculate the slope. So slope is rise over run, or vertical change over horizontal change. So I'm going to be starting at 15, and then it goes up to 26. So I can either mentally do that, or I can subtract the values. 26 minus 15, and that is 11. So it's going up 11 points. And then the run, in this case, is height. So we're starting at 72 and ending at 82. 82 minus 72 is 10 inches. We want to interpret that, so you can use a calculator. 11 divided by 10. I'll split screen with Desmos right now, just to have it. It's going to be close to 1, a little more than 1, right? 11 divided by 10 is 1.1. So the slope, close that, 1.1 points per inch. So what does that slope tell you about the trend or relationship between the height and scoring ability? It's increasing, so we want to write a sentence using the wording. So for every inch taller someone is, they tend to score 1.1 more points per game. Okay. Question number 3 is going to ask you to compare your line and slope to someone else's. Is it identical? Is it close? Is it really different? Most people's should not be identical. The only time they'd be identical is if you copied. So don't copy someone else's line. You're going to make your own, and then it should be close, but probably not identical. And you want to write down what their slope was. So let's say I had a different line. In fact, I can do that with maybe another color. If I had chosen a line more along, let's say here, let's use the yellow one. If I used this one, I would probably choose, I'd probably choose these values. I would probably use 74.18 and 84.29. And I would find the slope between those values. So I would do the rise, which goes from 18 to 29. So 29 minus 18. And that's the rise, or the y values. Over run, which is height, or x values. And that's from 84 to 74. And that I would get, oh my goodness, what do you know? 11 over 10. I used different points, but I got the same slope, 1.1. So same slope, which means they're parallel, but the y-intercept would be different. We're going to talk about the y-intercept in a few days. It's not going to matter for today's lesson. So that's your goal on this worksheet. You are going to approximate the line of best fit that you think is the best. You're going to find the slope. Make sure you check your spacing and subtract the y values and the x values. Feel free to use a calculator when you do that. All right. Work hard, please. Be polite to the substitute and get your work done.